Okay, welcome to lesson 11.1. This is kind of a daily math section, so we're going to talk about some daily math. These are things that are going to be functional throughout your lifetime. And so take special note, pay special attention. I grabbed a couple of, I think, good example problems for you guys to work on that are going to be fitting for things you might see down the road. First part is about percentages. So the word percent comes from the Latin percentum, which means per hundred. You've probably learned a bit about this already, I would suspect, in your 12-ish years of schooling. Hopefully learned some different methods. So I'm going to talk about a couple methods here about how we can find percents. A percent is the ratio of some number as compared to 100. So an example here, 15 compared to 100 is 15%. 125 over 100 is 125%. So these are some ways that we're going to try to get it into a common nomenclature here with the percentage. So what do? We have to divide and then multiply whatever we get by 100 and then add a percent sign. Literally, that is kind of the easy way to do it as far as changing a fraction to a percent. So an example here, we have 17 twentieths. We're going to divide 17 divided by 20, take that number, multiply it by 100, and then add a percent sign, and we're going to get, who's got their calculator handy? Anybody? Am I just talking to myself here? I hope not. I am talking to you guys and my other student who's not present at the time. It's going to be, this is easy. This is easy math right here. Yeah, 0.85. We take 0.85 times 100. We get 85. We add a percent sign to the end of it. Bam, 85%. Another example here, 5 eighths. 5 eighths. 5 divided by 8 is? You guys not know these? You must not work with measurements very often. No, that's definitely not. 0.625. So 0.625, we take that, multiply it by 100, 62.5%. Bam. So changing a fraction to percent, pretty straightforward. Hopefully you have some of these methods down already. Next, to change a decimal to a percent. Well, in these examples, we were turning it into a decimal and then multiplying by 100. Same thing is true here. We multiply our decimal by 100 or move the decimal to the right 2 times. That's kind of the simple method by which we do it. So, for example, 0.235, to turn that into percentage, it's going to be, move our decimal 2 spots to the right, 23.5. Thank you, student in the front row. Another example, 0.007654. What percent will this be? This would be 0.7654%. All we're doing is multiplying our decimal by 100 or moving that decimal 2 spots to the right to find the percentage. So we can divide numbers by 100 or move the decimal to the left 2 times if we want to go the reverse. To change a decimal into a percent, actually it should say change a percent into a decimal, my bad. So 35%, what is that going to be in decimal mode? Young lady in the front with the baby. 0.35. Very good. What about 1/4%? Young man with the calculator. 0.25%, which converts to 0.0025. Okay, so you should hopefully be able to flip back and forth between these. Hopefully this isn't brand new to you. If it is, make sure you read through the section here. A Yahoo question of the week. Now, Yahoo is kind of getting, I don't know, out, if you will. But it asks, at what age do you consider someone old? Out of the 3,496 responses, 1,017 said 80 is old. What percent of the respondents felt that the age 80 is old? How do we set this up? We take the number that we... Yes, the number we have that is, so 1,017, divided by the total number of, which is 3,496. And then we take this, solve it out, multiply by 100, and bada boom, bada bing, about 29%. So we can do some approximations as needed. Okay. Example number 2, in 1996, U.S. presidential election had 96,456,345 people voted. Of these, 47,402,357 people voted for Bill Clinton, 39,189,755 voted for Bob Dole, and 8,085,402 voted for Rob Perot. And lastly, 1,769,830 31 voted for other candidates. Find the percent of voters who voted for each candidate. So how do we do this? Is over of. So our total number of is 96,456,345. So we'll take each of these numbers divided by this number, multiply that by 100 to get a bunch of stuff. So for Clinton, here's our division, about 49.1%. For Dole, here's our division, about 40.6%. For Perot, here's our division, about 8.4%. And other, here's our division, about 1.8%. Any questions on this? So far, so good. When we talk about percent of change, so this is when we're looking at change, we take the current amount minus the previous amount and divide that by the previous amount, taking that quantity and multiplying by 100. Here's an example. In 1999, the MLB team with the most improved record was the Oakland Athletics. Did they make a movie about that? Was it called Moneyball? You have to check. In 1998, the Athletics won 74 games. In 1999, the Athletics won 87 games. Find the percent of increase won from 1998 to 1999. Well, what you're doing is you're taking the number that you have, 87, minus the number you had, 74, divided by the number you had, 74, and you multiply that by 100. This would be important for, say, you're getting a raise, or say you're getting some kind of an increase in something, or maybe a decrease in something. You can calculate what percent increase or decrease it is using this method. Yes, sir?
How do you do percent again?
Decimals to percent. Okay, let me pop back real quick. If you have a decimal, you just multiply it by 100 and add a percent sign. Okay. Good question. Quick review. All right, moving on to our next one. Selling price. Percent markup on a cost. So the price it is minus the cost of it divided by the total cost times 100 is going to show you what the markup percentage is. So Holden Hardware store pays $48.76 for glass fireplace screens. They regularly sell them for $79.88. At a sale, they still sell them for $69.99. Obviously, these numbers need to be bigger than the cost. How do we calculate? Find the percent markup on regular price. We're going to take $79.88 minus the cost divided by the cost multiplied by 100. So we have $79.88 minus $48.76 divided by $48.76 times 100 gives us about a 63.8% markup, which is kind of standard, I think, in retail. Then on a sale price, we do the same, but now we're using 69.99. 69.99 minus 79.99 divided by 88 gives us a markdown of about 12.4%. Okay, so the sale price is 12.4% lower than the regular price. As you're answering your questions, make sure you're looking at what's being asked so you know what to look for. Example 3, Melissa wishes to buy a house for $87,000. This might be you guys, and I can tell you $87,000 house is not going to get you much in 2024. To obtain a mortgage, she needs to pay 20% of the selling price as a down payment. Determine the amount of Melissa's down payment. How do we calculate this? Well, down payment is 20% of the selling price. So when we see this, our D for down payment is going to be 20% times $87,000. We convert these into decimals so that they work better. 0.20 times 87,000. So she needs to show up with $17,400 to use as a down payment. Example number 4, about 10,340,000 or about 47% of Iraq's population is younger than 15 years old. What is the population of Iraq? So basically we have two examples and we need to calculate out the thing that's missing. So the population under 40 or under 15 is 47%. That's a lot. So we take our total that we have, 10,340,000, and that goes on this side of the equal sign, and we know that 47% times whatever the population is our number. So we just calculate down to decimals. We divide both sides by 0.47, and we get a population of 22 million people in Iraq. Now, I'm guessing this number is probably higher since this was published. But that's interesting that, 20 so years ago, about half of Iraq's population was younger than 15. That's a lot of kids. Okay, here's your homework. For 11.1, it's on pages 524 to 527. The majority of those problems you can solve using what you learned here in our lecture video. Some of them you might need to dive in a little deeper into the textbook, but to really get a good, strong understanding, you might want to read it anyways. That's it. See ya.
It's only for one thing I don't do the most efficient.